So this is the required action to keep IC constant. So this method of bias compensation does not need a change in IC to affect the change in IB, because this I naught and IC naught are almost same, because I naught and IC naught are almost same because they are made up of same material. I have told you the transistor and the diode are made up of same material. So whatever value I naught is going to increase or decrease, the same value IC naught will also exhibit. So effectively they get cancelled out. So which will ensure that the collector current is going to be same. Which will ensure that the collector current is going to be same in the transistor. Any doubts in this variation in IC not? So we have specifically seen first compensation technique we have seen in general using thermistor and sensistor. In general, if IC is going to change, how am I going to make my circuit act by itself to ensure the Q point to be stable? Then we have seen the two types of diode composition specifically for VBE and IC naught, because compared to beta, VBE and IC naught are going to have a larger temperature dependence in the operation of your BJT. That's why we have seen separate circuits on how to tackle the variation IC naught and how to tackle the variation in VBE. See, it's all reverse logic. If something is increasing, I have to reduce that in the opposite way. So for that, what component I am going to add in my circuit? When you see that IC naught is increasing, I want to reduce IC naught. So have a reverse bias diode in the equation. So if this IC naught is increasing, this I naught will decrease to make IC naught constant. So that is a simple technique. It's just like you are adding something and you are subtracting, get back the same thing you do in max, right? So when you add something and when you subtract something the same, immediately you will get back the same number. Same thing, 4 plus 2 minus 2. When you do that, you get back 4, right? Same thing we are doing. In IC naught, I am having a reverse bias diode to subtract I naught, how much ever IC naught is increasing. Same way, when you are going to see the variation in VBE, when VBE is going to increase, I am going to ensure that there is a diode always to see that the VBE is decreasing, so that this VD and VBE will get cancelled. So these are the very famous compensation techniques available in BJT circuits, which are used to make nullify the variation IC naught and VB in an effective manner. So any queries or doubt you have so far in the bias compensation techniques?